Considering set G, which is a set containing 1 and negative 1, let's verify if this set is a group under the usual multiplication. Now, we have a lot of conditions that should be satisfied before we could say that this set is a group. But all of this would be easier to solve if we are going to start with this given Cayley's table here. This Cayley's table allows us to plot the results if we are going to apply the given operation on the elements on G. So that would mean this area here is the product of 1 times 1 under usual multiplication. So 1 times 1 is 1. Okay? 1 times negative 1 here is negative 1. Next, negative 1 times 1 is negative 1. And negative 1 times negative 1 is positive 1. These are the entries on our Cayley's table. And with this, we are now sure, of course, that it's non-empty. We have the elements and we have the result as well. The set is non-empty. At the same time, we could see that our results here are just either 1 or negative 1, and both of them are elements on our set G. This would tell us the closure property here also holds. The other conditions, the G1, G2, and G3, will also be satisfied easily if we are going to look into this idea of our Cayley's table here. So let's start with G1. We are going to, first, I forgot to mention here, let star be the usual multiplication. I just need to represent it like this so that I could just simply use star as I go forward. Starting here, star is associative in G. Okay? There are many ways to check associativity. We could look for pairs, or three different elements of the set, and subject it into the usual associative property like this: A star B star C is equal to A star B star C. Or we can just simply invoke the associativity for integers. We have here since, okay, associativity holds in real numbers in general under usual multiplication, or let us just use the notation I represented earlier, under star, then and we can also add and here, and we have elements of G which are 1 and negative 1 are also element of real numbers. Then we can say here that associativity also holds true for G under the same operation. Okay, so with that we can just say here that star is associative in G. Okay, so the first condition is already okay. The first condition has been met. Let's proceed now. Of course, we just simply need to make some statements here since we have specific items here, and there would be or we need longer time for us to really look into the samples of associativity for each of the elements here. Let's proceed to G2. Let me change my color here. So let's have G2. G2 is where we are going to look for the identity element. So let's have A element of our G. Find E, which is element as well, that's element of G, such that you have A star E is equal to E star A equal to A for all A element of G. We know that our operation star is actually usual multiplication, and we know that the identity for usual multiplication is 1, and that is already an element of our G here. But let's still check it further. If you're going to continue with this symbolically or algebraically, A star E under usual multiplication is AE. E star A is EA, or since they are commutative under usual multiplication, AE. We have both answers now the same here. So if we're going to equate it with AE with this equal to A, and if we're going to divide A both sides, we'll have E which is equal to 1. And again, this is the identity element for multiplication, and for this case, it's also an element of our G here. This would mean G2 is satisfied. There exists an identity element for our set. With this, let's proceed to G3. G3 is for the inverse. So let A element of G. We're going to find inverse of A, or A inverse, also an element of G, such that we have here, what do you call this one? A star A inverse is equal to A inverse star A is equal to E, which is equal to 1. I told you earlier the Cayley's table will be very important here, as we're going to look at and go back to our situation here. Of course, actually, I forgot to really say that this is also being captured by G2 already. Look at our item here. Which of the elements, since our identity here is 1, okay, our identity is 1. Okay, our identity is 1. Okay, where do we get 1 here? Speaking of here and this one here. Okay, that would mean if we're going to multiply negative 1 by 1, I mean you will have negative 1. 1 times 1, you will also have 1. And at the same time, this is very important as we look for our inverse, because our inverse, we have now that we have two elements that are G, we have different inverses, or we have inverse for each of the elements. So if our A is equal to 1, its inverse is something that when we are going to multiply with 1, you'll get a result of 1. So going back to our Cayley's table, for 1, where can we get 1? Here, it's actually 1 times 1. Therefore, the inverse of 1 is 1 itself. Or we can say here, like this symbol in symbolic form, the inverse of 1 is 1. And this is an element of G. How about if A is negative 1? What is its inverse? That is the area where we get 1 here as well. So for negative 1, its inverse is also negative 1. Okay? So its inverse is also negative 1. So the inverse of negative 1 is negative 1 itself. And this is also element of G. With these two, it's satisfied. We can say that G3 is satisfied. If only one inverse can be found in our set and the other cannot be found on that set, then G3 is not satisfied. But since both of them are elements of G, then G3 is satisfied now. So with G3 satisfied, G2 satisfied, and G1 associativity is all satisfied, we can now say that our set G, set containing 1 and negative 1, is a group. Okay? Or let me change the color so that it would be emphasized. Let's have here, right? Sorry, let me erase this first, just like that. And I have here, yeah. We could say here that G, which is set containing 1 and negative 1, is a group under star, to which we defined earlier as the usual multiplication. This is how the answer, this is how we show the answer for this given item. After identifying our Cayley's table or completing our Cayley's table, it's easier for us to look at the results. Thank you very much for watching.